So the key equations, among the key equations and formulas, equation and formulas. Okay, so the very first is the basic probability mass function, PMF, okay, which is equal to the probability that y, okay, the response variable is equal to k. Okay, so it is equal to e raised to power minus mu raised to power k divided by k factorial. Okay, this is a very basic formula. Okay, so for a specific count k, okay, this PMF is used to observe or find the probability of a specific count, which is k here. Okay, it means, for example, let's suppose the probability that we have 20 customers in the supermarket, or we have 100 customers. Okay, so that 100 or 20, this is the value of k. Okay, so probability that a number of customers is equal to 100. Okay, so this is the PMF. This is how we use this equation to find the probability that we have exactly 100 customers in the supermarket. Okay, and from the previous data we have the value of the mean. Okay, so what we do is we use the formula. Okay, so from the previous data we must have a value of the mean people coming in the supermarket per hour. Okay, so that can be used here. If we put it over here, okay, we can find the probability that we have 100 customers in an hour. Okay, we can use that. Okay, so this is the basic PMF. Okay, we will use this equation in the linear model also. Okay, in the generalized linear model or Poisson regression. Okay, the second equation. Okay, so we have mu I, which is equal to the expected value, okay, of the response variable such that we have x for certain value of x. Okay, so this is equal to e raised to power beta naught plus beta 1 x1 plus beta 2 x2 and so on, depending on how many factors do you have. Okay, if we want a generalized form, so it will be equal to beta naught plus beta I into xi. Okay, this will be the generalized form, and it will be equal to mu I, which is equal to the expected value of the count, such that we have a factor x, okay, which explains the count. So the basic interpretation of this equation is that, for example, 1 unit increase in factor xi, okay, it multiplies the count, okay, the customer count, for example, here, by e raised to power beta I. Okay, this is a basic interpretation. Okay, now the third thing, okay, the third equation is the length function, okay, or the log linear model. Okay, length function, or we can say the log linear model. Okay, what does this length function do actually? Okay, it actually converts this multiplies, okay, into the additions. Okay, so we have the expected value or the mean, okay, equal to this e raised to power. Okay, so this is the in a multiplicative form. Okay, so in order to make it linear, okay, so we take the log of both sides. Okay, so it converts it into a linear model, which is also called linear predictor. Okay, so the log link function, okay, it converts into a linear combination of the explanatory variables. These xi's are the explanatory variables. Okay, so it converts it into a linear form, just like a linear regression model. Okay, depending on how many predictors we have or how many explanatory variables we have. By explanatory variables I mean the xi's, okay, the number of x's that we have. Okay, so we use actually the maximum likelihood function, okay, to estimate the betas. Okay, the parameters betas, these are estimated using the MLE, maximum likelihood estimation. Okay,